and the track and where it all started. Then we'll talk a little bit about what we did to develop the C7 tire, and then we'll actually talk about some specific traits and characteristics about the new tires, and have a wrap up and conclusion. Right here, you just heard everything to know about me. I've been Michelin since I got out of college, and I've spent all my career in high performance tire development. Some big things there is I did the first zero pressure tires at Michelin, so I did run flat, started run flat at Michelin. And one of the biggest things I'm proud of is being able to work at American Le Mans, with the American Le Mans series. I've been with American Le Mans since the start in '99. And this June will be my 14th trip to Le Mans, and looking very forward to that. There's a couple people in the room, this reminds me I have to mention, that really before I get deep into this. The first one is Stephanie Brindley. Now this presentation started off as an engineering presentation, and Stephanie polished it off to be something more interesting, and she does a great job with our marketing and communications. Then another person in this room who plays a big role in the development of tires is Jim Merrill, right down here, because I'm working with him and we work together, and with his skill as a driver and engineer, that's where a lot of these characteristics come from. And then my beautiful wife Vicki, who loves Corvettes, and she keeps on looking at them. She saw the price of the new C7, I'm like, oh God. But yeah, I told you to buy some, but luckily they're not for sale yet, so that gives me a couple months to save up. Okay. And it's not just me involved in this. We have a pretty deep team back in Greenville, South Carolina, our development team. There's a bunch of guys there, and unfortunately those guys couldn't come today because they're back at the plant working, but a handful of these guys I think are going to be able to come to the NCCC event this summer, which is actually the week after Le Mans, so we'll be coming back from Le Mans, but we'll have a couple of these guys come out here and do another presentation. You'll get to meet some of the other guys that contributed to the Corvette tires. A little bit about Michelin. Michelin is the largest tire company in the world. We make about 22,000 tires an hour all around the world. 3 research and development centers. Greenville, South Carolina, 6-hour drive east of here. We also have the center of France, Clermont-Ferrand, France, is about 4 hours south of Paris. And there's also a research and development center, our Asian center in Tokyo, Japan. Almost 120,000 employees worldwide. Invented the radial tire. Another really important point here is we have this C3M automated, flexible, advanced manufacturing process, and that's the process that builds the tires for the C7 Stingray. That process is highly automated, is highly proprietary. I met the Bowling Green plant manager today, and we talked about trading tours in the plant. I couldn't offer that, but it's essentially a process where I used to be embedded in the plant. I'd do my design work in the plant. I'd hit return on the keyboard. All the information, the tire design information, would go across the network, and a robot would start to build the tire. So it's highly flexible and automated, and it's our most advanced process. And the fact that we keep it secret means that it's probably the best in the world. Our headquarters, again, in North America are Greenville, South Carolina. The North American headquarters up there, I call that place the Crystal Palace. I don't think any managers here, but I only go there when I get in trouble. And usually I explain things and then I'm out of trouble. The place where I spend all my time is at the test track in Lawrence. Lawrence is a very southern town way out in the countryside in central Carolina. You can see there are track layouts. We have ride circuits in here. We do low speed tests, and then up here is our handling track. We do a lot of our max handling high speed tests. And then over here is our research center. And in the last 5 years we've had a very aggressive campaign to beautify the campus, and that was the best shot I could get. I wish I had a helicopter, but we have a nice campus there where we do research and development. Now we want to get to the story about the track and where it all started. Michelin and Corvette's relationship started at the track. and it's with Corvette Racing. 2004, Corvette started running on Michelin tires. Since then, Corvette has been a 5-time Le Mans category championship. That's in the GT1 class as well as GT class. 5-time American Le Mans team championship. 48 wins in GT1, 8 wins so far in GT or GT2. We even had a couple of Green X championships, which also is very important in today's environment. And in 2012, we were very happy to celebrate the first GT manufacturing championship. And with the car number 4, they also won at Le Mans that year. And car number 4 won at Sebring, the first race of this year. So that was a really exciting way to start the 2013 season off. And why do we do this? Well, the catch line that Michelin always uses is we race to learn, we race to win. I like to say opposite direction, but we race to win and we learn at the same time. But we consider the racetrack and everything around the track, you know, all aspects of race cars, which are not only tire engineering, aerodynamics, mechanical, engine. We consider that a full-scale test lab. And we try to learn as much as we can when we're in this extreme environment of racing. And a great example of that is Le Mans. Le Mans is run not only on a permanent circuit, but it's also run on public roads. And I have many pictures of Le Mans where you see the street signs and directions and kilometers to the next village. So you learn from public roads there. And this picture right here is a great picture of rush hour. Just like us coming through Nashville this morning at 8 o'clock. But there's the Le Mans rush hour. Okay, tire development for the C7. I want to talk about, I call these arenas, and I don't want you to think this is a 3-ring circus because it could, the first thing I thought of was, maybe that's not good, but I'll say it anyways. But there's 3 areas in tire development where we see a lot of transfer and exchange of information between street tire development and the race tire development. The first arena, I'll call it, will be the modeling and the analysis side. Now, this is very much what occurs at our campus there with computers and labs and testing. The next arena of transfer is design. There's many elements of a race tire that are also found in a street tire and vice versa. And the ultra-high performance street tires that are on the new Stingray, they have a lot of the same properties and rigidity, stiffnesses that our American Le Mans or Le Mans race tire would have. And then the last arena of transfer of technology or methodology is in testing and validation. You know, we use racetracks to prove these cars out. We use, when our driver suits up in the ZR1 to go out, he's got a helmet, he's got a 5-point restraint system. You know, it's the same stuff that Tommy Milner does when he's running at Sebring. So your tires are not only developed to give you mobility on a road to go to the grocery store, they're also developed, especially for the new Stingray, to give you mobility at a world-class race level. So now if we jump into a little bit of the modeling stuff, and this is where you have to stay awake so you can win the tickets. But computer modeling, this is what I studied in school, is very mathematical and geeky. But what we do is we model, we write mathematical equations, and we try to learn as much as we can about the structure and the function of the tire using our computers. When I was first out of college 27 years ago, if you ran a simulation to predict the deflection of a tire, like this picture over here, it would take about 10 days. And so if you made one mistake in one of the nodes or somewhere in the mathematical analysis, you wouldn't know you made a mistake for 10 days. Now it's about 10 minutes today, so that's a great improvement. And, you know, 3-dimensional, so it's just really just like having a building, going through all the investment and time and tooling to build a tire. We can do that all in a computer, a virtual tire. So I have 3D analysis. We also spend a lot of time looking at the contact patch, straight line running or cornering, to understand properties of the tire, everything from wear to comfort to noise. And one of the great things that is really big news for the Stingray, the Pilot Super Sports on the Stingray, is that we're using this, for the first time, we're using the same software that we used to design the Le Mans and American Le Mans tires. We applied that software to design our Stingray Pilot Super Sports. Okay, now we jump from analysis to what do we look at in design? When you build a tire and design a tire, what is modified? What do you adjust? What plays a role in the outcome of performance of that tire? So this is a solid model of a Pilot Sport Cup 1 ZP that's on the ZR1 and Z06 today. So when I'm running all my computer simulations, some things that I'm looking at are the tread pattern, and not only the size and position of grooves, but the shape of the crown of the tire. If you look at the shape, how much curvature is in the shoulder, is there a nice apex in the center, or is it flat? So all those things I'm looking at in the computer models, and you can easily increase the number of variables that you're running 10, 12, 15 to 80 or 90 simulations to find the optimal combination of all those. Then once you move below the tread pattern and the shape of the mold, you start to get into the internals of the tire. First thing you come to, tread depth. How much tread depth is optimum? Second thing is the cap ply. You guys know what I'm talking about when I talk about cap ply? Typically you have two steel belts at angles, and then you have a ply that's run at 0 degrees circumferentially around the tire, so it's going in the same direction as the rain grooves. So we spent a lot of time optimizing the cap ply. In a lot of tires on the market today, that cap ply is actually a tissue. So that a manufacturer will take a tissue, just like a sheet of paper, and they'll wrap it around your tire and make a joint, and bam, voila, that's your cap ply. But at Michelin with the Stingray tires, we can control the position, the tension, the cable for every one of these. So if there's 115 turns on that tire, we can change every one of them to a specific tension and position to meet the best performance of the Stingray. That is, it gives us really good control of the contact patch. And that cap ply is made out of Kevlar, so it's as strong as steel. It doesn't give up. Belt angles are next. After the belt angles, we'll have one belt angle combination for the front tire and a different belt angle combination for the rear tire. And in fact, if you look at the Stingray Z51 and compare those belt angles to the Stingray Standard, they're all going to be different. This is very much tailored for the specific application. After the belt angles, then you have a lot more of the rubber components in the tires. So we are tuning and changing, adapting the stiffness, the hysteresis. Hysteresis is loss of energy. That means a spring is like perfect, gives back all the energy, but something with hysteresis absorbs energy when you move it. So you play with those properties. Another thing that's really very cool and helps us work for making these tires match race tires is they're ZP tires, and they have run flat or sidewall stiffeners. Race tires have sidewall stiffeners too, but we use the run flat inserts to play the role not only as for a run flat zero pressure tire, but also to give race tire stiffness. Here are some more contact patches again, just real quickly. Again, we look at straight rolling for wear, rolling resistance, comfort, and noise. And then another area where we really made a lot of advances in learning, especially with the Corvette, is learning on how to model a contact patch when it's cornering. When it's in a max cornering situation, and understanding how that contact patch shape looks to get the maximum grip. And in the last slide, you saw the contact patch shape, but I also look at going from a straight rolling tire to a cornering tire. How fast does that change? How reflexive is the contact patch? Does it adapt very quickly? That's usually better. Then we go through and look at all the internal stress and strain in the structure of the tire, and that's what you see up here in the upper right-hand corner. And then we also have programs today where we can take the stress and strain and we can apply the material properties, and we can figure out what the temperature is in the contact patch. The temperature when the tires get hot, they usually go off. You guys that race on the track, you know that after a while, if your tires get too hot, you might be losing grip. So we want to get to a good operating temperature, but keep it consistent. And then the last thing is we work a lot with the cap ply, and the commercial name is Tworon, but that really is Aramid. And we can control the tension of that Tworon, so we can control the shape of the contact patch, especially with the belt angles that we use to get the best torsional stiffness in the tire. We can make it flat, again, like that. So all these things that we can do with tire models, a great step forward in the whole development process is that these tire models can talk to vehicle models, and that's something we always want to work on and push, because then, you know, Corvette's not making an investment to build a prototype car, and you know, we can go through a lot of scenarios just with, you know, on the computer, which is very rapid, fast, and low cost, and we can get to a better solution at the end. Okay, here's tire design. The last thing, I hit on a lot of these properties, but some of the things about the Stingray C7 tires that are really close to our Corvette Le Mans racing tires. I'll just point out a couple of them in here. One of the things is in the tire design, we're always looking to find new tools, new golden nuggets. Like, wow, we never knew that made such a big difference. But here we have Pilot Super Sport. That's an evolution of or it's really a revolution, I would say, of the Pilot Sport 2. Pilot Sport 2 is pretty good. I think a lot of you guys might have Pilot Sport 2, but you're going to see a difference when you go to the Pilot Super Sports. That's one thing. You know, we're always driven for continuous performance improvements. And the Pilot Super Sport tread sculpture is really a step up. The fact that it's asymmetric, when you look at tires, racing tires, the rain tires, lots of those will be asymmetric in racing. We not only the sculpture or tread pattern, but also the sidewall. On our tires, the interior sidewall, which would be the side over here on the left, is very stiff. That serves a function of it transfers torque, not only in braking and acceleration, but also in cornering. So having a very stiff sidewall on this side is optimum for transferring torque. But having stiff sidewalls also takes away from the grip capability, because a stiff sidewall is going to make your contact patch smaller, and your tire is not going to grab as much on the ground. So on the outside of this tire, over here on the right-hand side, we use a lot less stiffer rubber. That sidewall is more flexible. It's great for comfort, ride, wear. Also, if you lean on it real hard in a corner, 1G, 1.1 Gs, it's really going to increase in size and grip up well and give you a good grip. The other areas, we use the belt angles of these tires are very close to the belt angles that are used in American Le Mans racing. We might adjust them just a little bit to meet some other performances on the street tire for straight line highway wear. And like I said earlier, that whole tread pattern and profile of that mold is designed using the same software that we use for race tires. Okay, this is one of my favorite ones, but I guess I'm not certified to talk about it because I'm a mechanical engineer. But these are the guys I work with all the time in the rubber and polymer departments. We're going to talk a little bit about the things that you can find in tires. The first picture on the left there is natural rubber. We still use natural rubber in tires. Lots of times natural rubber is good for rolling resistance and tread life. The next picture there, those blocks of rubber, and that's the real color of rubber. It's not black. It's kind of a yellowish color. That is synthetic rubber that is usually made from petroleum products. But we use a combination of natural, synthetic rubbers. Anybody knows that this is in the middle? Carbon black. That's why new tires are black. We've made them other colors before. We don't make them colored tires now, but we have made orange, yellow, red. And what about way over here on the right-hand side? Silica. Silica is another mixer, another filler that we use in rubber. It's gained a lot of popularity since the 80s. There used to not be hardly any silica in tires, but it's really good to help improved rolling resistance and fuel consumption, as well as wet grip. There's another filler that we use in tires, and I'm not going to tell you exactly what's in the Stingray tires. They're too new yet, and I don't want to give away any secrets to help anybody else out. So when I'm talking in general, clay. How many knew that there was clay in rubber? I always tell people when they ask about what's in rubber, I tell them red Georgia clay. That's the best stuff. So Georgia clay works the best. I'm just joking about that. And then over here, this is the best picture I could pull up for all the other chemical ingredients. In tires, there can be anywhere from 100 to 150 different chemical ingredients. And there are some things in the chemicals that I think that will surprise you. And again, this is not what's in the, I'm not going to tell you specifically about the Stingray tires, but some unusual things that we mix in the rubber. There's metallics in there. Cobalt, titanium, can be in some tires depending on what the application is. And if you go all the way to the other end of the spectrum and think about natural and green things, sunflower seed oil. Who knew sunflower seed oil can end up in your tires? There you go, one person. It's not, that's one of the latest things I've heard in the internet lately that other companies are advertising. And orange oil. The skins of orange, you can squeeze that and get oil out of that. That's another ingredient. So we're looking around at all kinds of different areas to find chemicals and ingredients that can boost the performance of the tire. And so it's really quite complicated and complex process for the chemicals. And the main thing that we're looking for here is for grip. And there's two components of grip. One is the adhesion surface, the adhesion of the road surface to the rubber, and the other one is a mechanical adhesion, which has to do with the road surface deflecting into the rubber, kind of like, and making a mechanical grip with Velcro. But all those different ingredients affect the way this process occurs to cause grip. The last arena of our three-ring circuits is testing and validation. And this is a really big part because we learn stuff here all the time. I've learned way more things at the track side, working with the guys at GM or our test drivers. And whenever I go to the track, I like to take a lot of our younger engineers down there just getting into the project because they're really observant and they see things. Look at this, look at that, Lee. What does that mean? And that helps stimulate ideas and come up with new ideas to make the tires better. And these are some of the guys. The guys here there's a young tire designer there. There's a couple guys that design molds, and there's another guy in the background there that's a computer programmer. So I bring these guys, and they give me a lot of insight by learning. I watch and see what they pick up on. But we test at probably the best test course in the world is Milford. Milford was designed to be an analytical and validation track. It incorporates a lot of the corners and sections of really famous racetracks and tracks around the world. So Milford Road Course, we do a lot of work there. We work at our test track in Lawrence, South Carolina. We go to Road Atlanta a lot, Virginia International Raceway, Spring Mountain by the National Corvette School. And then GM goes to Nürburgring, and I've done stuff at Mossport, and we take these tires on the road. They're not only track tires, we also take them to the road. So we're testing them all over in South Carolina, and of course in Michigan, Arizona, and Germany. Here's another, a little bit more analytical slide about the testing, and what I want to show is what the heart of these laboratory testings are. This is force and moment testing, so we can do vehicle dynamics or integrate tire data to the vehicle dynamic situation, so we can come up with the best system to get around the track the fastest. But in the heart of this right here, we have a cornering force curve. This line across here is slip angle, and on the vertical is cornering force, Fy. And we can measure that using a flat track, which you see up there. That's actually a Michelin race tire, and that's at the new facility at Virginia International Raceway, the National Tire Research Center. So we can measure slip angle of that tire on a flat track and make these plots here. Once we know this property, it's kind of like a torque and horsepower curve for your engine. So once we know these properties of the tires, the idea is we can put that into models of the vehicle and find out what the best shape of these curves should be. What's the optimum shape of these curves to have the fastest time on the lap? I like this slot right here. This is Jan Magnuson at Road Atlanta, and he's up on 2 wheels. The reason I like this shot right here is because cornering force depends not only on slip angle, but it also depends on the load or the normal load on the tire. And since Jan he's got the Corvette up on 2 wheels only, he just really simplified all these mathematical equations we have to solve down here, because instead of being 4 wheels, he's on 2 wheels. So it makes the equation solve better. Another very interesting part about flat track testing is I told you a little bit about temperatures of the tire and how they affect, but we can look at the surface temperatures of a tire with infrared and infer and learn things about how efficient the tire is working. Here's again a little bit more of our testing done at Lawrence. This is our driver, Brandon Sturgis. Subjectivity is a big part of it. It's easy to drive. You want a system, a vehicle and tire system that is easy to drive and fast. Sometimes you can have a system set up that's very fast, but you're risking breaking your neck doing it that fast. So he's on the clipboard, he's writing his subjective notes. Yeah, this was easy, or no, this was difficult, or depending on what he finds with the tire combination. And right next to Brandon here is a V-box. You guys know what a V-box is? V-box is it's an instrumented box that has a GPS sensor in it, so it can tell position. It has yaw rate sensors, so you can tell how fast something is spinning or turning. It also has accelerometers, so you can tell braking acceleration, lateral acceleration. It measures all the vehicle dynamics components that are interesting from an engineering standpoint to tell you how well the car is driving. And if you look down, I don't think that's too focused, but this is just the short list of the stuff that we're measuring here. We have, I can't even read it up this close, but there is lateral speed, longitudinal speed, steering wheel angle. There's a lot of information here. You can take all that information and you can plot it on a graph like this. This graph is our track that we do handling evaluations in here. Can you guys see the difference in these two plots? The color represents the yaw rate, or how fast the vehicle is turning in every corner. In this plot right here, you see the red spot right here, so it has a very high yaw rate in this particular corner. In this plot on this side, it's got a little bit of red, but it's a little bit more spread out. But it has a higher red value right here. And actually, Brandon, when he rated these tires, he liked this one better. That's the combination that he wrote better. So we, he gives his subjective note and say, yeah, this set is better than that set. But we can also boil this down and dissect it and see even closer why he made that choice, and they can help us gain some understanding about, do we need to make the sidewall stiffer, make the tread stickier, and find out what to work on. Now we're going to take a break. I'll get my voice back. But if you guys have questions, throw your hand up and we'll go right on it.
Wait, we want the forms back. Okay, guys, hold up.
Yes, sir. The question was with with a little bit of negative camber on the Corvette, will that affect tire wear? And that if you have a lot of camber put into your car, yes, you can affect the tire wear. But the tires are designed around the factory specification of camber, which I believe is right around -1 degree on the new Stingray. We're designed to give you a good wear life at that rating of camber. If you want to go to a higher camber, you can certainly do that for a track, and as you go to higher and higher camber, and if you leave that for driving on a normal highway for straight head driving, it won't be very good for the tire wear. So it's a situation. If you're only going to have the car set specifically for a track, yeah, go for higher camber. But then when you go to
the standard tire that you're putting on the C7 is going to give good even tread wear anymore.
yes, sir.
Question? Is the Pilot Super Sport tire that you developed for the C7, Z51, same compound and construction as the non-ZP tire that's available today for the Grand Sport, for instance?
Okay, the question was, is the tire we developed for the Stingray, the standard and the Z51 Stingray, is it the same compound that we're using on the standard tire today for the Pilot Sport 2 on the Pilot Super Sport? And the answer is no. We use special compounds specifically for the Stingray.
How will one know what you're getting when ordering tires if not by size, and you've got different? Well, I mean, how do you tell which one you're getting?
The best way to do that is to know that if you buy a ZP tire in Pilot Super Sport and the size for the Corvette, you're getting a tire that is specifically designed for the Corvette. So 245, 40, 18 for the standard C7 front, and a ZP is going for the Corvette. Also, there's a GM spec number on the tire, and also anybody that sells these tires, it will say standard Stingray fitment. So you can go to the tire rack, it will specifically give you that information. And we might go just a little bit longer because I think some of these questions are answered in the next couple of slides. This break was to get me a glass of water, thanks, babe, and to collect the raffle. So, yeah. Okay, now I'll get into the specifics of these tires, like you're saying. Okay. 2014 C7 Stingray. There, just a little bit of information. The tire we chose, and you know this from earlier, it's our latest and greatest, the best that Michelin has for the ultra high performance realm, and that's the Pilot Super Sport. And for Corvette, we made a ZP, which it sets it apart from the other Pilot Super Sports. And this one's specially designed just for the Stingray C7. We have new technology that we've learned how to transfer from the racetrack to the street track. We also have new tread compounds. We especially tailored the cap ply even more for this specific application. On the standard Stingray, we actually used a lot of our advanced, more rolling resistance efficient materials, which is something we've never done before. So we still have a tire that's very handling capable, but it also has really good fuel economy too. Asymmetric run flat inserts, again, like I told you, that really helps the street tire behave more like a real Le Mans race tire. And some of the things that occurred to come about with this tire is over 3 years of development. So this has been, we've worked on this for a long time. You guys have asked me about this stuff before. I've had a gag order. I couldn't say anything, so I can finally talk about it now. I can tell you about all this stuff. This is what we've been doing. 12,000 hours of tire design and research, thousands of miles on the test track, tens of thousands of miles on the road. We wear test to prove out that the wear would work well at the camber levels that were set by the factory. Okay, again, for the standard Stingray, that Pilot Super Sport was made to provide a total or balanced performance package. That is, it's going to give you longer wear life. It's going to give you a little bit better wet traction and wet capability, and it's total performance, better comfort. When we go to the Z51 package, I want you to know that tire was designed specifically and focused very intently on track performance. On this tire for the Z51, these are +1 inch, so they go, instead of 18, 19s or 19s and 20s, it's the same width. But the tire structure and the contact patch are even more specifically optimized for the track. And we use a dual tread compound here. And one of those compounds is made in the same factory that makes the rubber for Corvette racing. So it's coming, it shows how close we are to the racetrack. We're actually using rubber that comes out of the same factory for the Corvette racing tires. And that, if you look at the Z51 tire, it's actually a blend of not only the Pilot Super Sport, all the good things that the Pilot Super Sport bring to the table. It also has some Pilot Sport Cup technology in there. Not only in rubber compounding, but also some of the internals of how we engineer the contact patch. And right here we just have the standard Stingray. Those are the sizes there. Keep this in mind if you have a C6, a standard C6, that those tires will fit your car as well. So if you want to upgrade from PS2s or anything else you have on there, you can try those tires on the C6. So they're 18 and 19 inch Pilot Super Sports. It's in the neighborhood of 1 G of cornering capability, so it's very capable on the track. Is we have a lot of low energy, low rolling resistance compounding in there to help fuel economy. Wear life is TQG, Uniform Tire Quality Grading System. It's government regulated, and we're moving. Our Pilot Sport 2 used to be 220, so these tires are now engineered to have a wear life of 300. So there's an improvement in tread life and wear. Improved ride comfort, noise, wet properties, stopping distances. If you go to the Stingray Z51 package, here again, like I said, it's a +1 inch on OD. That makes you guys still have the cuts going around back there? And you can see the Z51s, they have shorter sidewalls. That shorter, stiffer sidewall helps with the precision and handling, makes it a better handling tire as well. And again, the dual racing compounds, one of which comes from a very exclusive plant in France where we make our racing tread rubbers, but they're optimized for high temperature and wear and the load and power of the C7 Stingray, C7 Z51 Stingray. And really those tires are very special, and if you look at all the Pilot Super Sports out there and you look at all the Pilot Sport Cups out there, this tire it bridges that gap a little bit. It takes a Pilot Super Sport, it gets a lot closer to the Pilot Sport Cup, and it gives you some longer wear life, some wet traction improvements of the Pilot Sport, Super Sport line. And then I like to show this slide because it just shows a hierarchy of what's out there for the Corvette. If we start at the bottom, we are going to have Pilot Alpine 4. They're going to be winter tires will be available this fall for the C7 Stingrays, both the standard and the Z51. We have Pilot Sport All Season Plus ZPs that would be available for the standard Stingray, and we're working on getting a project to move that to Pilot Sport All Season 3 and have them zero pressure and specially tuned for the Corvette. Hopefully we'll get that pretty soon. And we still have the PS2 ZPs. There's Pilot Super Sport non-ZP, so we have the sizes that will fit the C7s and non-ZP and Pilot Super Sport. And then we have the Pilot Sport ZP, which are OE tuned, and the Pilot Sport Cup. Then we go to commercial racing slicks, and then you go to the tires that no one in this room can get, which are except for Feehan, if he's out there, he can get the Tommy Milner, and yeah, okay. And then right here again, I just list the tire lines or the type of tires that are available for each size. And I think that's about it, Stephanie, is that right? And now, you know, we've got 10, 15 minutes, we can do the drawing.
Yep. Some questions.
Another thing is I have some temperature probe up here, some cuts. If any of you guys want to take a look at or discuss how to look at a tire when it comes off the track as far as measuring the temperature profile to help you set up suspension alignments, camber, or pressures and stuff like that, you guys come up here and we can do a little talk about that real quick too.
So you guys turned all the forms, right?
All forms are in?
Then
Okay, we'll do questions. Yes.
On the Z06. Thank you. On the Z06, the new one, when they come out with it, how are you guys going to think about changing the tires so it's even more higher performance? If you can tell us.
We don't have any information about any. We know the Z51 and the standard. That was 36 months backwards. 2010. Yes, sir.
What recommended tire for us? We have a C6 standard driving in the south. Which tire do we want?
Standard driving in the South. Are you in Florida?
Will be South Alabama.
South Alabama?
Lower LA.
And you have a C6, I would try the new Pilot Super Sport ZPs. I would get that. That's an improvement over the PS2 ZPs that we've had on the replacement market for a while. I would get those tires. You don't have to worry about snow much, and I think they'd be fine. Yes, ma'am.
All these tires are only available now at any North American market, so they also available in my market.
One of the main reasons why we need to have a Pilot Alpine 4 is in Quebec is the law. You have to have, I think it's also the law in some place in California or Nevada to go over Donner Pass, I think in the winter. You have to have snow tires in one or two places in the United States and in a lot of places in Canada. So the Pilot Alpine 4 will be available this fall in Canada. The Pilot Sport All Seasons are already available in Canada, and the new Pilot Super Sport ZPs, they'll be available after the debut of the C7, so that will also be this fall. They'll be turning those out into the replacement market. Yes, ma'am.
Can you put that other slide back on, the one right before this? Yes, we did have another one. Thank you.
Yes, sir.
For track day type driving, on closed track, which of these tires do you think is going to work best?
Pilot Sport Cup will give you the fastest times, biggest thrill. The Pilot Sport Cup will usually be about 2 seconds faster than a Pilot Sport 2. What kind of type of car do you have? Grand Sport. You have the 18, 19 option tires. Yeah, the PS2s are not bad either. You know, you would get a lot more, depending on your driving style, you get a lot more wear life with those.
What is the wear factor
On the Cup, Jim wears them out pretty fast. It really depends on your driving style. It's hard to answer that question. But, you could have if you just go to a club event a couple times this summer, you might be able to use one set, 2 or 3 or 4 times this summer. I've heard that Kurt Benyon and Harlan Charles that just don't wear, normal highway wear life. They've got over 10,000 miles, 14,000 miles. And Tom, how much? 4,000. I think he drives real hard and spins the real tire. Is that right? So he's got 4,000 miles on his tires right now, and they still look good. Yes, sir.
We're rating number tires, standard tire.
Yeah, the wear rating number on a Pilot Sport Cup is 80. Yeah, the wear rating number on the Pilot Super Sport is 300. The wear rating on the Pilot Sport 2 is 220. Now try and... It's a function of compound, it's a function of the belt angle, because the belt angle and the tread pattern optimization, all those things affect the stresses in the contact patch. And you might be able to have one stress distribution that gives you a nice highway wear profile, but maybe that stress distribution is not as good for ultimate grip on a track. So there's always a compromise in there. It's tread compound and also the internal construction and shape of the mold. Z51, there is actually the design goal. We work very closely with General Motors on that because it's an original equipment project, but also Michelin has a warranty on that, and the warranty is 30,000 miles on the Pilot Super Sport. But because these tires are not the same in the front and rear, you can't rotate them from front to back, so they have to make 15,000 miles. So your Michelin will warranty those tires for 15,000 miles because you can't rotate them. Based on the testing that I've seen, I think that you guys will probably get around 20,000 miles with the Z51 tires. And so another fact, let me just give you another fact about tire wear. Everybody knows how to wear the tires out fast, is to drive the car hard and fast. What's something else that affects tire wear that you guys might not know? Air pressure, air temperature is what I was looking at. I know you guys know how hard you drive it and the air pressure. The next thing is air temperature. The compounds that you use in summer tires, if you buy a tire and it's a summer tire, if it says on their summer tire in the category, those compounds, they don't wear as well when it's 35 degrees outside. So if you're in lower Alabama and if your minimum temperature in the wintertime is 65 degrees, you're probably pretty good. You can drive a PS2 at lower temperatures, but as long as it's not wet or no snow or ice out there, you could drive that kind of compound at lower temperatures. And they work very good once they warm up. But in just normal driving, if the road surface temperature is 33 degrees, because of the nature of the polymers and the compounding there, it's going to wear at a rate almost 30, 40, up to 50% faster than it would wear if the road surface temperature was 80 degrees and you were driving. So that's a good reason. If you are in the Midwest and there's many days that you can drive your car in the wintertime, if you did have an all-season tire for the wintertime, that would be a better choice. Yes, sir.
Jim Miro shared some times with us and left out the big one at the end, but that's okay. He indicated that the new tire is so much better that at the narrower widths of the C7, it's still a faster lap time than the Grand Sport on the Gen 2 Goodyear tire. Did you guys do any comparisons against the Grand Sport on your tire on the currently available Super Sport?
Not really head-to-head comparisons. I know of that tire, but one of the whole goals of using the narrower tires was to increase the efficiency of the tire. Make the tire the dimension that we're having on the C751, even though it's narrower, it's not a 275, 325 combination, but pack in, concentrate as much handling capability into that narrower tire that, that's a natural thing, is that you want to, when you progress, you go to the next generation, you want to be able to beat the times of the last generation. So that shows you how special these tires are. They're really much a refined concentration of a lot of good stuff transferred from the track to the road to make a narrower tire work at that level.
But you've only compared yourself to the competition, not to your own previous generation tire in that comparison that we saw. How was the new Pilot Super Sport
compared to a PS2?
No, compared to the Pilot Super Sport that's currently available for the Grand Sport C6.
The non-ZP.
Non-ZP.
Yeah. I haven't done that comparison. And I would say that the one for the Z51 will blow the doors off of it was a tire designed for the general replacement market. That means it has to go on all those other foreign sports cars, and it was not specifically tuned directly for the Corvette. And I would say you got at least a second or more.
Even in the wider widths of the older tire.
No, this 2050.
Yeah, even at the wider widths, you're not going to get the same thing. It doesn't have the sidewall stiffness, and it doesn't have the compounds.
Thank you.
Sure.
It's a normal driver. Compare nitrogen versus
Regular air. I got chemistry 101. Regular air is about 65% nitrogen, 80% nitrogen, somewhere in there. 80% nitrogen. The main reason for, especially in a sports car performance reason, for why you would want to use nitrogen is to make sure that what you have inside the tire is dry. If you had humidity in the tire, and you also, do you know the operating temperature of a tire when it's on a racetrack?
You're asking me?
Yeah, 220 degrees Fahrenheit. It's over a boiling point. So you go over the boiling point of water, you have water inside the tire, the pressure is going to, instead of the pressure increasing linearly, so you can understand the handling level evolves slowly, and you understand and anticipate. All of a sudden, the pressure jumps up like crazy, like a pressure cooker, and your rear end's loose all over the place. So that's a good reason to have nitrogen, or at least make sure you have dry air. I've been to places where I've taken and put air in my tires, and at the same time I was putting air on in my tire, I've seen water coming out of the end of the hose. So that's not a good situation. Sure thing. Yes, sir. In the middle.
Will the Pilot Super Sport Zero Pressure be available for C6 transport and 06 sizes?
Pilot Super Sport Zero Pressure in the 275, 35, 18, 325, 30, 19. I'm pushing our marketing people to do that. I'm hoping we can get that done. So I should have told you before, you filled out those cards. If you put on those cards, we want this kind of tire, because that way those guys in marketing and research will see that. But Stephanie is going to help me take that message back. Well, there's a lot of, if you went back to some of the things that Taj was talking about in the packaging of the vehicle, you know, it's very complex situation. So anywhere you can save space, it helps them incorporate systems that can enhance the vehicle for a lot of other performances, not whether it be power or the way the chassis and the suspension works. There's a lot of reasons why you want to have more room.
One more question.
The question is the improvement between the old and the new. Efficiency-wise, well, the best way to explain that is that the newer, narrower tires can deliver the same handling as the older, wider tires. Rolling resistance efficiency. Sorry, okay. Difference, and I can give you a specific answer on that, and what I'll do is I'll use our own product, Pilot Sport 2 zero pressure tire in the C6 dimensions versus Pilot Super Sport at probably a mile per gallon. And there's new regulations in Europe, you know, it's coming everywhere. Everybody is striving to try to, yeah. One more question.
With respect to the museum and they want to close at 5 o'clock, I think we'll thank everybody for the questions. And,
Come see me right out
that's why everybody stayed.
there. No one fell asleep.
No, we all stayed because we wanted to hear the presentation.
We're going to get my wife to...
What's this worth, $2,000?
It's worth
Set of tires.
a set of tires. If you have a ZR1, you want some PS cups, you got them with this.
I do.
Fa Chan, I think it says.
guy.